Hello. So we're going to give folks a little bit to trickle in. But just to give a quick intro, what we're going to cover today is a technique for quant on the GRE where we're looking at variables and choices. But as people are coming in, I'm interested, let me know in the chat box, please, where you're calling from and what your experience is with the GRE, if any. We'll give folks a minute or two before we get started. Okay, so it seems like maybe folks are feeling a little shy, and that is super okay. So hi, I'm Jerry. I'm going to be your instructor tonight. Got an hour-long session tonight where we're going to go over an important technique for quant of what happens when we see variables in the choices of a question. And the technique we're going to look at is called what I'd call the plug and check method. And this is a way to take problems that look really intimidating and make them a lot more manageable. So we're just going to learn how to use it, and then we're going to practice it for the hour today. At the end, I'll be able to take questions you have in general about the GRE. So to start with, here we've got a very straightforward question, a little bit more straightforward than we might see on the GRE, where we're just asked for the area of this rectangle. And I would bet a lot of you probably can find this without much difficulty, right? You would just do the base times the height. But let's use this to learn about this technique, because what we might notice here about the setup of the problem is that there are variables in the choices, or VIC, we might say. And when I see variables in the choices, I'm going to use this technique we'll call plug and check. And the basic idea of plug and check is I'm going to replace those variables with easy numbers and then solve. So rather than dealing with X, I'm going to deal with a nice easy number. So if we think of this in 3 steps, step 1, I'm going to pick a number for the variable. So let's pick a nice easy one, like X equals 5. Step 2, I'm going to solve using that number and find my target. So I'm no longer worried about X and X plus 1. I'm going to forget these are even here. And instead rewrite this as 5 and 6. And if I do that, my area is going to be 5 times 6, which is going to be 30. 30 is now my target value. Step 3 is where people sometimes get a little confused here. So far, this is fairly straightforward. Step 3, we're going to plug that number into the choices and compare to the target. So, choice A, I get 5 squared, which is 25. Choice B, I get 5 squared, plus 5, so 25 plus 5, which is 30. Oh, well, that looks good, but it's important to check all of them. I'll explain why in a second. 2 times 5 squared. Okay, so 2 times 25, so 50. Great. So I see it's not A, it's not C, it is B, and great, I got it, I'm done. This is a way that we can take problems that might be way more complicated than this one, where the algebra might be intimidating, or the setup of the problem might be really complicated, and by plugging in these numbers, make it so much easier. So we just pick a number, solve using that number, and then plug the number into the choices and compare to our target value. Now, I said it's important to plug into all the choices, because you want to be on the lookout for a duplicate answer. This is going to happen rarely, but it can happen. And it's just sort of bad luck when it does. So let's imagine that choice D were 6x. Well, then when I check this, I do 6 times 5, which gives me 30. This might happen where I get more than one answer that matches my target. If you find a duplicate answer, plug in another number and only check those answers. So we can check another number here. Let's try now like x equals 3. To make these sides 3 and 4, my area would be 12. And then let's check A and we'll check D. So A is going to give me 3 squared plus 3, which is 12. D is going to give me 18. Great. That eliminates that duplicate answer. And I see, oops, not A, I meant B there. And I see that my answer has to be B. So it's rare that this happens, but you still want to make sure to do this step of plugging into all the answers, just in case. So that's the technique in a nutshell. We're going to practice it a bunch today. But before I move on, are there any questions about how this works or anything anybody would like clarified? Okay, I just want to remind you, feel free to use the chat. I'm going to be asking you some questions soon. I would love if you answered them in the chat. And if you have any questions, feel free to reach out. So this is the plug and check method. And the key is, when do I use it? I use it when I see variables in the answer choices. So that means when I'm starting a problem, I'm going to take a look at those answer choices and say, are there variables here? Do I want to use plug and check? So let's take a look at another problem here. Give you a second to read this. So this is a problem that to me is like, whoa, what's going on here? This is quite confusing. There's a lot to take in. We've got 2 variables. We've got these really complicated looking expressions. We've got this stuff about m is less than n. They're multiples of 4. The thing I'm looking for, it's all very complicated. But the fact that I've got variables tells me let's use plug and check. So I'm going to rewrite the question picking two numbers. So they tell me they're multiples of 4 and m is less than n. Great, let's pick some nice easy numbers there, like 4 and 20. And so we can just kind of think of it like we're replacing m and n with 4 and 20. So now 4 and 20 are multiples of 4. 4 is less than 20. Duh. Which of the following equals the number of multiples of 4 greater than 4 and less than 20? All right, so first I want to figure out just what does that mean? Like how many multiples of 4 are between 4 and 20? So I've got 8, 12, 16. That's it. So my target value now is 3. And now I'm going to go through here and just plug in and do the arithmetic. So 20 minus 4 divided by 4, work that out, that ends up being 3. And of course, this arithmetic would take you longer than it's taking me with this prepared slide right now. But I'm showing this one less as do it, which, you know, if you're watching the recording, you could pause it, go back and actually try it, but more to say like, okay, this complicated question becomes a lot more manageable once we're dealing with numbers instead of variables. Now, what this doesn't do for you is the difficult work of unpacking this part of the question, which is just kind of tricky here. And this is one of the ways that the GRE can get tough, right? Just figuring out what's the question asking me can be pretty tough. All right, so let's try another one. I'm going to give it to you. I want you to try using this method and send me your answer when you have it. I'll give you about 2 minutes to work on it. Oh, I'm hearing that the chat is disabled. I think I maybe just finished that. Or fixed that, rather. So you should be able to send chats to everyone now. Sorry about that. Okay, so let's look at this problem. And because I see I'm dealing with variables, this is another chance to use plug and check. So best way to do this, they say they're odd integers. Let's pick two easy odd integers, like 1 and 3. And then if we plug them in, this is still like, this looks more annoying maybe than it is, right? But we have to do a bunch of arithmetic, whatever, we can do arithmetic. And when we do that, we see the answer is B. Any questions about either this problem or this method? Okay, so let's try another problem here. This is one where, again, it feels, if just reading it and not using this method, this feels pretty intimidating to me. But we've got B, B. I'll give you a second to actually try it, but remember to plug in a number and then check. Please send me your answer when you have it. Okay, please send me your answer if you haven't already, even if it's just a guess. Okay, so let's pick a nice, easy number for B. Maybe somebody let me know in the chat, what number did you pick for B? All right, good. I think I'm getting 1. I think that's a great idea. She reads 1 book per week. That's already a lot of books, right? And each book has 100,000 words. So she's reading 100,000 words per week. And we know there's 7 days in a week. So if we're looking for the words per day, that would be 100,000 divided by 7. And I could just get that on my calculator. Or I could see that I've got 7 and 100,000 here. So let me plug in 1 and I'll just keep this as my target. So let's plug in 1 to each of these. Here I'd get 100,000. That's not going to work. Here I'd get 100,000 over 7. Looks good. 700,000 over B. No, thank you. 7 over 100,000. Nope. 100,000 over 7 times 24. Where's that 24 even coming from? No, thank you. Our answer is B. And so to my eye, part of what plugging a number in does here is it lets you think about this as a real world scenario, where if I had to ask you conceptually how you do this, maybe you'd be able to say, oh, I do this, right? I multiply the number of books by the number of words and divide it by the number of days. Maybe you can do that. But I think it's easier not to conceptualize it, but to just do it. And to think about it in these concrete real world ways. That's part of what this allows us to do. So it eliminates algebra and it lets us think more concretely. So let's try another one. Again, send me your answer when you have it. Okay, send me your answer if you haven't already. So we've got a rectangle, and we know the width is twice the length. So I'm going to pick a nice easy number for W, like 2. The width is twice the length. Now I'm looking for the area. The area is going to be 2 times 1, or 2. This is now my target. And I'm going to plug it in over here. So here I get 2. Oh, that's nice, but I should check some more. Here I get 8. I'm going to see my mental math skills on display here. 12, 2, and 1. Ah, interesting. So I can get rid of E, C, and B. But I should test another number to check which is right, A or D. So let's pick another number now. Say W equals 3. I've got 3 and 2. So my area is now going to equal 6. This gives me 3. That's no good. I don't need to test B, C, or E. I'm just going to check this one. Here I've got 9 divided by 2. Oh, whoops. It wouldn't be 3 and 2. I'm so sorry. These are terrible numbers. We don't want to pick 3 because we're dividing it by 2. So let's do 4 instead. So sorry about that, everyone. Try 4 and 2. There we go. So here our area is going to be 8. Here I've got 4. That's no good. Here I'm going to get 16 divided by 2, which is 8. That's what we want. And so my answer is D. So you may notice as I messed up there and picked the wrong number, sometimes you pick a number and it doesn't work super great. Now, could I have gone through had I been paying a little bit closer attention and realized it would have been 3 and 1.5? That's totally fine, but it's a little bit annoying. So it's up to you. Do you want to work with a decimal or do you want to pick a different number? Sometimes when I teach this, students end up having a lot of anxiety around picking the right numbers. My feeling is give yourself like 5 seconds to come up with a good number and then just pick the number that's coming to you. Sometimes you can pick a number that makes things easier, but like ultimately, if you have kind of gross numbers, that's fine. Just work with them. You've got a calculator anyway. Any questions or thoughts about this? Or difficulties folks are having? Okay. So let's try another. Get a little bit harder now. Again, try picking a number, thinking with that number so you can make it like a concrete real world story. All right, let's work through this together. So a clothing store bought 100 shirts for a certain amount of money. They sold all the shirts at the same price for a total of $50. What's the store's profit per shirt in dollars in terms of X? All right, so let's imagine they bought 100 shirts for, let's say, $10. They sold the shirts in the same price for a total of $50. So the total profit is equal to $40. Notice again how having a number here makes this storytelling much more easy to follow. What's the store's profit per shirt? Great. So the profit per shirt is going to be 40 over 100 per shirt, the number of shirts. So we end up with, 0.4. This is now my target value. So let's look at this. 50 minus 10 over 100. That's going to give me 50 minus 0.1. That's no good. 50 minus 10, that gives me 40. That's no good. 5 minus 10, -5, that doesn't work. 0.5 minus 10, -9.5, nope. Oops. And 0.5 minus 10 over 100, or 0.1, which is 0.4. Perfect. And so notice this last step, I don't need to try to understand conceptually why this works. I could waste a lot of time like trying to figure out why this is the right equation, but that would be a total waste of time. We don't need to do it conceptually that way. This test doesn't give you extra points for doing the math in a more difficult way, right? So we want to do everything we can to make it simple, make it concrete, especially in these kinds of like real world style word problems. The key when you do this is just keep good records. I wouldn't rewrite these phrases, but I would write this stuff on my page with A, B, C, D, E next to it. I would not just write A, B, C, D, E and cross out because it's important to have numbers there so you can refer back in case something goes wrong. Questions or thoughts? Okay. Remind you, please feel free to ask any questions, could be during a problem as well. Let's keep going. These are going to start getting a little bit more difficult. And through that, we're going to start seeing a couple of other content areas in the GRE. But again, I want you to keep recognizing this problem type where we've got variables in the choices and the question we plug in to make it easier. So send me your answer when you have it, please. Okay. So we've got here two trees. One's taller than the other. Oops. Tree 1, tree 2. And they have a combined height of 60 feet. The taller tree is x times the height of the shorter tree. Well, I'm a simple person. Let's let x be a simple number. The taller tree is twice as tall as the shorter tree. How tall is the shorter tree? So that's our goal. I want to know this height. So what's tricky here is I now have to think about the fact that, well, there's another variable involved here. Let's call it h for the height. The shorter tree is h. The taller tree is 2h. And this is really the trick here. If you saw, I did one of these last month about 2 variable word problems. A lot of them are like this, but in this case, by plugging in x equals 2, we can kind of make it a 1 variable word problem. That's easier. But that's the trick here, is we need to then pick a variable for the height of the tree. Having x equals 2 makes this a little bit simpler. So now I can add the trees together to say 60 total. Divide both sides by 3, get 20. This is now my target value. Now I go back here, plug in x equals 2, and see what I get. So here I get 60 over 3, which is 20. Well, that looks good. But let's look at the rest of these. 60 divided by 2 is 30. Nope. 30 divided by 2 is 15. Nope. 60 minus 4, which is 56. No. And 30, oops, 30 minus 10, also 20. Oh man, bad luck. Let's pick another number. So let's now say x equals 3. So that would mean this is h and this is 3h. So I have 3h plus h equals 60, 4h equals 60, h equals 15. All right, try this again. Look at A and E. So I get 60 divided by 4 equals 15. That looks good. Over here, I get 30 minus 15 equals, oh man, rough luck. This is gonna happen. Rarely, never happened to me, but it can happen. So let's try x equals 4. So we've got h and 4h. This is becoming pretty time consuming. On the test, I would probably just take a guess and move on rather than work this out more, but let's do it. So I've got 4h plus h equals 60, 5h equals 60, h equals 12. All right, hopefully this will figure it out for me. Here I get 60 divided by 5 equals 12. I like that. Here I've got 30 minus 20 equals 10. All right, finally I can get rid of choice E, see the answer is choice A, and move on. Now, as you're doing this, like I said, we don't really want to plug in 3 numbers if we can avoid it. It's literally never happened to me before, but it can happen with some bad luck. As we're doing this, sometimes you get kind of an intuition. Like I was doing this and I was like, oh, I think this A is actually right based on what's going on here. Just from the fact that like my last step here is doing this 60 divided by 4, or 60 divided by 5, or 60 divided by 3, that felt right here. Versus this felt so unlike the math that I was doing that if I had to guess between them before plugging in that third number, I'd choose choice A. Now, again, I want to highlight the difficult part of this problem, realizing that you have to come up with H as your number for the small tree. Questions or thoughts about this? Okay, got a couple more for you, and then we'll wrap up. So once again, I want to encourage you to pick numbers, spend a little bit of time on this one, thinking about the setup and figure out how are you going to pick numbers for this setup. Send me your answer when you have it, please. All right. So we're told we have 4 consecutive integers. Consecutive just means one after the other. integers are positive and negative whole numbers, and 0, right? So things that aren't fractions. And we know A is less than B is less than C is less than D. So with all of this, you might think, all right, a nice version of A, B, C, D might be 1, 2, 3, 4. Pretty straightforward. I want the average of A, B, C, and D in terms of D. All right, cool. So I know D is 4. I'm going to use that over here. But for now, I'm looking for the average. And the average is equal to the sum over the number. So my average here is going to be 1 plus 2 plus 3 plus 4 over, I have 4 numbers. So it's going to be 7, 8, 9, 10 over 4. I'm just going to leave that as a fraction. I don't really care because we'll sort of see what happens here. And now let's plug in D. 4 minus 5 over 2. Oh man, maybe now I'm regretting leaving that as a fraction. So I'm going to use the calculator now and just get some decimals. So this is going to be 2.5. I'm going to let that be my target. And I'm going to be super ready to just use the calculator here and get these. So 5 over 2 is 2.5. So 4 minus 2.5 is 1.5. Not what I want. 4 minus 2 equals 2. Not what I want. 4 minus 3 over 2, which is 1.5, gives me, oops, 2.5. That looks good. So let's try the others. 4 plus 1.5, that's going to equal 5.5. And this one sure looks complicated, but let's try it. All right, so 4 times 4, 16 minus 6 over 7. So 10 divided by 7, no. Just goes to show you if you're randomly guessing, it's not necessarily the most complicated one that's right. So my answer is C, excuse me. Forgot to cross out D. And it doesn't matter what numbers you pick. I like 1, 2, 3, 4. You could do 0, 1, 2, 3, whatever you feel like. Okay. Questions or thoughts? Great. We've got a raised hand. I would love to hear that question either in the Q&A or in the chat, please. So Anna's saying, I actually wrote A and B and C in terms of D. Yeah, that'll totally work, right? So if you call it like D minus 3, D minus 2, D minus 1, and D. Yeah, that's absolutely a way to do it. Do I recommend this strategy is the question. Well, the moral of the story of this lesson is plug in the numbers because it makes things easier. But if you're doing this and you're like, this is actually easier for me, I don't want to do this work of plugging the things in here, that's okay. I think as you're learning the test, a really important thing to do is try doing problems multiple ways. Try doing it with the numbers, try doing it algebraically. Ask, which is easier for me on this kind of problem? Generally speaking, some people like to do algebra more, some people like to work with numbers more. What I want you to really internalize, though, is the fact that you have a choice when you're taking the test. I think where a lot of people go wrong is they see something like this and they only think of the algebraic solution because I'm looking at variables, so I got to use the variables. If you realize that you have a choice, you may say, okay, I could plug in numbers or I could do this algebraically. You know what? I'm going to do it algebraically. That's fine with me. Cool, go for it. There's nothing wrong with that. Does that answer your question, Anna? Great. Okay, let's try one final problem and then we'll wrap up. Send me your answers when you have it. Okay, so we're told x is odd, all except which of the following must be odd. So whenever I see one of these except things, I find it helpful to write on my page what my goal is. So I'm looking for something not odd. That's my goal. And all right, these look pretty annoying. So to make it easier, I'm going to plug in x equals 1. That'll make these calculations a lot simpler. So 1 plus 4 plus 6 is 11. That's odd. I don't like it. B. 1 plus 5 plus 3 equals 9. Nope. C. 1 plus 6 plus 7, 14. Aha, looks good. But I'm going to keep going just in case. 1 plus 7 plus 1, 9. Nope. And 1 plus 8 plus 4 gives me 13. Excellent. So I only have one answer, and that answer is C. Now, I want to think about Anna's question from earlier about what would be the other way to do this? Well, there are odd-even rules, which you can learn. And they go like this, right? So like an odd plus an odd is even, an even plus an even is even, an even plus an odd is odd. Even times anything is even, odd times odd is odd. All right, so maybe I know these things. I always have trouble remembering these somehow. I'm impressed I got them at this time. But anyway, I might know these and I might do an analysis here and say, all right, if x is odd, well, x squared, that's odd times odd. So this would be like odd plus an even plus an even. All right, so then odd plus even, that's odd plus an even is odd. But I'm just like thinking so much more. And I could do this for all of these, but oh man, that's like, I think, pretty annoying. I'd much rather than thinking about abstract rules, think with concrete numbers. Again, part of your job when taking this test, make the test easier for yourself. Whether that's how you think through a problem in like a real world scenario, or how you solve a problem, something like this, where it becomes very conceptual if you don't use this method of plug and check. So again, to recap, if I see variables in the choices, I'm going to replace it with everyday test cases and then solve. And so part of what this means is make a habit of glancing at the answer choices before you start solving. Decide how to solve before you start solving. And this is a big idea for the GRE in general, that if you rush in to solve a problem before you have a sense of what's going on and what do I want to do, you're bound to make mistakes. You're bound to end up in bad scenarios. As you keep studying, I want you to think about, how do I put the test in my control? How do I identify the possible ways of solving a problem? How do I decide which one is going to be the easiest for me? So that's our lesson for today. I hope you keep practicing this. I hope you have a chance to use it. I hope it helps you out as you go forward. I'll stick around for a little bit. I'm going to turn off the recording, and I'm happy to take any questions about the GRE or anything else. But I want to thank you for a wonderful hour.